All right, in this section, we're going to talk about outcomes and type 1 and type 2 errors. When you perform a hypothesis tests, there are 4 possible outcomes. And I made a little table to talk about the 4 outcomes. The first outcome is based on whether or not the null hypothesis is actually true or whether it is actually false. So if we look at this column right here, if I can draw on this is the column that represents that in reality, the null hypothesis is actually true. So our first option is a correct outcome. We did not reject the null hypothesis, and the null hypothesis was actually true. So it's the decision to not reject null hypothesis when null hypothesis is true. And this is a correct decision, okay? That's one possible outcome. The next possible outcome is that H0 is actually true, but we end up rejecting it. This is what we call a type 1 error. The decision to reject the null hypothesis when the null hypothesis is in fact true is a type 1 error. This is a mistake. We define alpha, which I know we've used before, but I use alpha a lot in math, to be the probability of a type 1 error. So if you see alpha, that in this context, that's what it's going to be talking about. And alpha is the probability of rejecting the null hypothesis when the null hypothesis is actually true. The third outcome happens when the null hypothesis is actually false. And the first option is when we do not reject the null hypothesis when it is in fact false. This is called a type 2 error. So this is the decision to not reject the null hypothesis when the null hypothesis is actually false. We call this a type 2 error, and beta represents its probability. So beta is the probability of accepting a null hypothesis when a null hypothesis is in actuality false. And the final option is our final correct outcome. This is rejecting the null hypothesis when in fact it is false. This is a correct decision. You reject the null hypothesis and it is in reality false. We call this the power of the test. I like to capitalize it because it seems more dynamic. The power of the test. And this is going to be equal to 1 minus beta. Remember, beta being the probability of a type 2 error. And ideally, we would like this to be very close to 1. We would like the power of a test to be almost 100%. Let's do an example of type 1 and type 2 errors. A sleeping bag is tested to withstand temperatures of negative 15 degrees Fahrenheit. You think the bag cannot stand temperatures that low. Let's state the type 1 and the type 2 errors. Well, it's pretty hard to state the type 1 and the type 2 errors without first stating the null and alternative hypothesis. All right? We think the bag cannot stand temperatures that low. All right? So the null hypothesis is going to be the bag can withstand temperatures of negative 15 degrees. It's equal to the ability to stand those temperatures. And the alternative hypothesis will be that the bag cannot withstand temperatures of negative 15 degrees. All right, let's think about the type 1 and the type 2 errors. You can always go back to the chart if you need to. Let's just flip back. Remember, the type 1 error was reject H0 when H0 was actually true. So reject H0 when H0 is actually true. Let's think about it in this context. We want to reject that the bag cannot withstand temperatures of negative 15 degrees when it's true that the bag can withstand temperatures of negative 15 degrees. So the type 1 error is the bag can withstand temperatures of negative 15 degrees. So the H0 is actually true, but we reject it. The type 2 error, remember, is when the H0 is actually false. Type 2, H0 is false, and we accept it. Remember, these are both errors. They're both not the right choice. Type 2 error, the bag cannot withstand temperature, so we're rejecting the null hypothesis, but we think it can, right? So those are the type 1 and type 2 errors for this example. You might want to think about which one of these is more dangerous. In my guess, I guess it'd rather be 2. I would rather think a bag can't do it than be stuck out in the cold with a sleeping bag that can't withstand the temperatures I expected it to be able to handle. Let's do another example. I'm going to read this to you, then I want you to pause the videos, and state the type 1 and the type 2 errors. A group of doctors is deciding whether or not to perform an operation. I'm going to give you the null hypothesis. Suppose the null hypothesis H0 is the surgical procedure goes well. So the alternative hypothesis is the surgical procedure does not go well. State the type 1 and type 2 errors in this example in complete sentences. Pause the video and then come back and try and check your answer. All right, are you back? Now remember, this type 1 error means that the null hypothesis is true, but we reject it, right? The null hypothesis being the surgical procedure will go well. So the type 1 error is the surgical procedure will go well, but the doctors think that it won't. The type 2 error, remember, the null hypothesis is false. The surgical procedure will not go well, but the doctors conclude that it will. And again, I think probably in this example, the type 2 error is, again, more dangerous. That isn't always the case. Let's do one more example talking about alpha, beta, and the power of the test. A microbiologist is testing a water sample for E. coli. The null hypothesis is the sample does not contain E. coli. Like, as in, the amount of E. coli present equals 0. The probability that the sample does not contain E. coli, but the microbiologist thinks it does, is 0.012. The probability that the sample does contain E. coli, but the microbiologist thinks it does not, is 0.02. What are alpha, beta, and the power of the test? Well, let's remember that alpha is the probability of a type 1 error. And a type 1 error is when the null hypothesis is true, but we reject it. All right? The null hypothesis here is the sample does not contain E. coli. So that would be this example, right? The probability that the sample does not contain E. coli, but the microbiologist thinks that it does. Wait a minute, I did this backwards. They both say the sample does not contain E. coli, but the microbiologist thinks it does. So this is this example, right? The null hypothesis is true. The sample does not contain E. coli, but we reject it because the microbiologist thinks it does. This is 0.012. So that is going to be our alpha, the probability of a type 1 error, and that would be that the sample does not contain E. coli, but the scientist rejects that hypothesis and concludes that it does contain E. coli. And we are given that that is equal to 0.012. All right, so we figured out alpha. Let's figure out beta. Beta is going to be the probability of a type 2 error, right? And that's the probability the sample does contain E. coli, right? The null hypothesis is false, but the scientist concludes that it does not. And they tell us that happens with 0.002, so 2 thousandths. Such a hard word to say. Finally, what is the power of the test? Well, remember, the power of the test is always going to be 1 minus beta. In this case, it's 1 minus 2 thousandths, so that's 0.998, right? So that's the power of our test. All right, that's all for section 9.2, which covered type 1, type 2 errors, alpha, beta, and the power of the test.